All right, today we're going to look at angles. We'll talk about how to name them and some different angle types. You will also have an investigation that you need to make sure that you do after you watch the video. And think about what happens with the different angles that are formed. Think about their measures and those types of things. And I'll go into a little bit more depth when we get there. And then I will also post a video on constructing angles that you should watch on Tuesday night. But definitely make sure you take care and watch all this one, and make sure that you're taking notes on these, because these are replacing notes in class. That way we can take care of our assignment during the school day. All right, an angle. We'll talk a little bit about what it is and then how we're going to name it. An angle is formed by two rays that share a common endpoint. That endpoint that they have in common is the vertex, and the sides of the angles are rays. So if I ask you to name the sides of the angle, they're going to be rays. All right, so there's an example of an angle, and that vertex is common endpoint that they have right here. That's our vertex. That's point A. Our sides are rays, so ray AM and ray AT. And whenever we name an angle, we have two ways that we can name it. We can name it using 3 points, one on each ray, so the T and the M, so 1 point off of each ray, and the vertex. The vertex always has to go in the middle. Okay? The vertex always goes in the middle. I can change that, the way that that's written there, to where I can write it as angle MAT. Okay, I could write it as angle MAT is fine. As long as that vertex is in the middle, I can switch the order of the points that are on the rays. The other way that I could write it is I can also name this angle A. Now, the only problem with naming it as angle A is that's not a way that we can name an angle all the time. It only works, we can only name an angle this way whenever there's only one possible angle that we can look at. So, for example, this is the only angle that we could possibly be talking about. It's the only picture that's on here. So it's easy to call that angle A. However, let's say I draw a couple of intersecting segments there. Now I have 4 angles. So if I were to tell you that the vertex was A, I don't know which angle we're talking about. It could be any one of these 4 angles. It could be this straight angle here. There's a lot of different things that it could be. So we don't know which one it is. So we couldn't just name this angle A. I would have to have other points on these rays in order to be able to get a name for them. All right, a couple other things about angles. The measure of an angle is the smallest amount of rotation. And that's all, whenever we talk about the degree measure of an angle, it's how much we have to rotate one ray to get to the other ray. That amount of rotation is the amount of degrees of the angle. So whenever you hear that, that's what that means. And that shortest amount of rotation, that is the measure of the angle. Now, there's a flip side to that, and that's the reflex angle. The reflex angle is the largest amount of rotation between the two rays. Okay, so that's a big difference on what we're going to talk about. All right, now this slide, this is on constructing angles. We will come back to that in a different video, so I'm going to skip over that. All right, another term that we need to know is an angle bisector. We talked a little bit about what a bisector is in class. A bisector divides something in half, whether it be an angle, a segment, whatever the case may be. A bisector divides something in half. So an angle bisector divides an angle into 2 pieces. Now, the angle bisector, by definition, it says a ray here. It could be a segment, it could be a line, but by definition, it's a ray. It divides an angle into 2 congruent angles, but it could be a segment or a line. So, for example, that picture there would be an example of an angle DAG, with angle bisector AW. Okay, so then I would know that these 2 angles, angle DAW and angle WAG, are congruent because of this angle bisector. Okay? And remember, that congruent stands for the shape. So I know that the actual angles are congruent. This down here, this little M, all that this M stands for is measure. Okay? That's all it means. that M just stands for measure, so let me type that out. And that's all it makes. So it's real simple. Whenever you see M in front of an angle like that, it just means measure. And again, I use the equal sign here because now we're actually talking about the degree value and not just this figure itself. All right, a couple other things that you're going to look for. Whenever I have an angle bisector like this, it divides into two angles. A way that I can show you that those two angles are congruent are these little arcs here. You'll have arcs there like this. Sometimes you'll just have an arc. Other times you'll have a tick mark through that arc. It means the same thing. It means that those two angles are congruent. It's not just a way for us to show you that on the picture. Okay, so those little arcs are, and sometimes the tick marks through, are what you'll see. And you'll see both throughout the year because both are widely accepted as ways to show congruence. And then on the next video that I'm going to post, it's going to be about constructing an angle bisector, and we'll watch that tomorrow night. All right, a couple other terms that we need to talk about. You know what parallel lines are. There are two lines that never touch. Well, in geometry, because we talk about multiple planes, we have another set of lines that never touch. Skew lines are lines that never touch, very similar to parallel lines, but they're non-coplanar. Okay, so you can think of drawing a line on one wall and then drawing a line on another wall. Those lines are never going to touch, but they're not parallel because they're on different planes, and that's what skew lines are. Okay, make sure you pay attention to this term. Do not be surprised to see an example of this on your quiz on Wednesday. I believe I have it on Thursday. Now, a couple other things about parallel and skew lines. Parallel lines, remember, same plane. Skew lines, different plane. That's the big key. Make sure that you remember that. And we would name the lines just like we would name the lines. All right, now these all should be familiar, so we're going to go through these real quick. A right angle is an angle that measures 90 degrees. An easy way to see that through a symbol is you've got that right angle symbol. Make sure that you only take something as a right angle if I tell you or you see this little box. It might be an 89-degree angle. Well, by the naked eye, that's going to look a lot like 90 degrees. If you don't see this box, it's not a 90-degree angle. So make sure you go with your symbols. Don't just assume stuff. Make sure you look for symbols. All right, we got an acute angle. It's an angle that measures 90 degrees. That's pretty simple, straightforward. Should have learned about that in middle school. And then finally, an obtuse angle. Now, this is something that I'm going to add to it. You might not have seen this before. It's an angle that measures more than 90 degrees, but here's the part that you might not have seen in the definition before. It also has to be less than 180 degrees. So more than 90, but less than 180. It has to be both. If it's 90, it's a right angle. If it's 180 degrees, it's something called a straight angle. All right, now, other terms that you should have learned already, they should be reviewed. If we talk about two different types of angles, complementary angles are angles that add up to 90, and supplementary angles are two angles that add up to 180 degrees. Okay, so supplementary is 180, complementary is 90. And you could kind of think of them as being in alphabetical order. The C in complementary comes before the S in supplementary. The complementary is 90, supplementary is 180. Okay, and we'll use that throughout the year to solve problems and answer different questions. All right, another term are adjacent angles. Adjacent angles are angles that share a common ray. Okay, now this ray here, we don't know that these two angles are congruent, so this ray is not an angle bisector. Okay, these two angles are just adjacent, they're next to each other, they have that common ray. Okay, we don't really have any special properties with those, we just know that they're next to each other. All right, now what I need you to do as far as your investigation, okay, you're going to draw a figure, draw two lines using a straight edge that intersect. Okay, make sure that I want you to measure the resulting angles, and measure those with a protractor, and come up with some conclusions about the different angle pairs that are formed. Okay, and I want you to make sure that you're prepared to discuss what you found in class tomorrow, because that's what we're going to start with, is this investigation. Okay, so make sure, and just real quick, just to make sure everybody's on the same page here, you're going to draw two lines, segments, rays, whatever, make sure that they intercept, and I want you to measure those four angles that are formed. Okay, and be ready to discuss those and what that means, and then I'll give you a couple different terms on Monday that give us, that help us to distinguish these different angles. Okay, so make sure you measure those, come up with some sort of conclusions.